That's a scatter plot. It's a number. So you have 0, 1, 2, 3, 4, 5, and 2 people like, oh, you already have.
Like, talk about it.
Well, one of them here. Well, it's like and more than one brother, everybody gets, so 5 people have one brother, so you put 5 dots above them. If they have 3 brothers, so you have 2 dots above them. It's basically a bar.
Yeah,
I was gonna say it's a lot like a bar graph.
Or when they're on a chart, they put cat heads on
Yeah, it's a whole thing.
and then they remove picture of the eye, and then it's just a bar. Okay? That's it. I wonder if they do that. Yeah, that's
Thank you. So now we're looking at our rules to determine if they are proportional. And, okay, so I'll just draw a name and we'll see, and then I'll talk about what Rochelle is talking about. Melissa? Yes. Do we look at our rules to determine if they're proportional?
We discussed that when you look at the rules, if there's nothing that is being added or subtracted after what's attached to your X or your N, or whatever the coefficient is attached to, then it's proportional, because there's a direct relationship to something happening to this is gonna affect the other side. Whereas if there was a plus or minus, then that's where we know that the things change.
That's interesting, isn't it? So, Melissa, how do you feel about that?
Well, I kind of conducted my own little experiment, and I just wanted to verify. I asked Jen, do both ways have to be correct in order for it to be proportional? So for
You mean an X to a Y or compared to an X to an X?
So for example, if it is proportional from going from an X to Y versus X to Y, but maybe not from X to X over X in comparison to Y over Y, does it have to be both ways or just one way in order for it to be proportional?
Both.
Both, okay. So, sorry, I just needed that for myself, and that's good.
That's okay.
We didn't get to finish our conversation. But, so I'm sorry, what was your question now? I just needed that for myself, because I was conducting my own little experiment over here.
I forgot what my question was actually.
A response to what I
yes.
said about the something being added or subtracted.
So let me
Do you
write a
agree or not?
table up here and let's see if it is proportional, okay? So make up a table, yes ma'am. Denise, did you read it?
No.
No, okay. So here's my table. And this is gonna be 1, 4, 2, 7, 3, 10, 4, 13, and I'm just making up these numbers. So I'm gonna call on somebody and you tell me if this is proportional. Why?
Because, okay. If you check it by putting your X over your Y, like 1 over 4 over 2 over 7, it is not the same.
1 over 4, 2 over 7, those are not equivalent.
Not equivalent.
Okay,
And then 1 over 2 and 4 over 7 are not equivalent.
so what is the rule for this one? Can y'all talk to your group and determine the rule for this one?
It's recursive. It's purely recursive.
One times 3 plus 1 times 2 times 3 equals Y. Figure that out. Right.
And that is.
See, I was like, I got zero. Write that, I would see.
How do you see another one?
Okay, so Brenda,
Yes,
we determined this is not proportional,
yes, ma'am.
so we are looking for the rule
Yes, ma'am.
that would describe this. Do you have one?
Do I have one, or did Roger?
Thank you. You're an Amanda, huh? Did your group have one?
The group, they had not created one yet. They found a recursive pattern. They found a
I
recursive.
have no idea what that is.
Recursive.
What are you talking about? Tell me what you're
Okay,
talking about.
so what the group discovered was if you look at the change from x1 to x2, it changed by an increase of 1.
Okay.
And if you had a change from 2x, we're in the x column this whole time, from 2 to 3, it's an increase of 1.
Okay.
And from 3 to 4, it's an increase of 1.
Okay.
If you go to the y column, there's an increase of 3 from 4 to 7, an increase of 3 from 7 to 10, and an increase of 3 from 10 to 13.
Okay.
So if you asked what something was for x that's in the near future, 5, 6, 7, 8, they could find it. If you asked what the y value,
They could find
sorry,
it.
the group would be able to find the
Your-
y
your
value, our group would be able to find the value of y if you asked what x was if it was 5, 6, 7, 8, 9. If you asked what the value of x was for 100, it would take some time.
So what is it for 6? What is the value of y for 6, Brenda's group?
19.
19. How did you determine that?
Well, 5, the next one on the end of the x, would be 5, and then that, we know that y would be 16.
Okay.
Following our same pattern. the next
Okay, so
one
you're,
is
so you're still adding on.
Yes.
Okay, all right, that's great. Anybody else? Oh wait, I need to draw. Let me throw you off by saying, how do you know? Either. I keep drawing people who aren't here, I'm gonna have to do something. Amanda S. Yay. Instead of Amanda B.
She doesn't look yay.
Well, I was just really excited that I saw this. I was like, oh, there's 3.
Do you wanna phone a friend?
What was your question? Can you repeat
The
it?
question is, what is the, the rule, like you wrote for these? What can you do to 1 to get to 4? What can you do to 2 to get to 7? What can you do to 3 to get to 10? And those have to be the same things that you do. So what is that? Do you have an idea?
I would think that it would be like x plus 3. But if I did like 1, so that would be my x.
Mhm.
So if I did like 1 plus 3, that would be 4. If I did 2 plus 3, that would be 5. So that doesn't fit my next y, which is 7.
So that's not the rule.
Okay.
So, can we draw somebody else? Why you think?
Yes.
Okay. Amanda S. I mean B.
I'm so excited.
Okay.
So we figured out that it's 3x plus 1 equals y.
Okay, let me write that down. 3x plus 1 equals y. Why? I mean, how do you know?
Well, if I substitute 2 for the x,
Yep.
3 times 2 is 6 plus 1 equals 7,
Okay,
and 7 is the y of the ordered pair.
okay, did that work here?
Yes, because 3 times 3 equals 9 plus 1 equals 10, and 10 is the y in the ordered pair.
Okay, and did that work here?
3 times 4 equals 12 plus 1 equals 13.
And here?
3 times 6 is 18 plus 1 equals 19, and 19 is the y in the ordered pair.
So you developed a generalization by looking at specific cases, right? Is that a habit of algebraic thinking? Remember we talked about that? Generalization. So y'all are thinking algebraically, that's exciting. So before we found the rule, we determined that this was not proportional. What causes this to not be proportional? Not Rochelle.
The plus 1.
A plus 1. So if you have a plus or a minus in a function, I keep calling them functions, in an equation, then it's not going to be proportional. It will not be proportional. So,
Ms. Browning,
yes ma'am,
would you repeat what you said about algebraic thinking?
one of the habits of algebraic thinking is generalizing. That's the whole goal of algebra, is to make generalizations looking at data. So we looked at specific cases and generalized that this would work for everything in this data table, assuming the things increase at the same rate. Yes, ma'am?
Question. So, when Ken came up with the rule, I started thinking, how would I like figured that out? So would it be correct, or not really, and this would probably be a trick, if they realized, like we first said, oh, it's x plus 3. 1 plus 3, 4, done. And then Rochelle's like, 2 plus 3 is not 7. And I'm like, ah. So then I started seeing when she said 3x plus 1, I'm like, well, the 3 is right there, and there's a plus 1 right there. 'Cause, but if you disprove the first one, like x plus 3, just what you first see, would that work normally?
Okay, I'm gonna go a little bit deeper in here than you would at the grade level that you're teaching, all right? Some of the people in middle school already know this, so help me out if I say things wrong, because I tend to do that when I have a headache. All right, so these are called finite differences. Okay, they're called finite differences. This is gonna stay a 1, this is gonna stay a 3. And what this gives you is your slope of the line. And slope is, as Rochelle has pointed out to me repeatedly today, slope is y over x. And some people will say rise over run, okay? Change in y over change in x. So the slope of this equation, if we were to graph it, is 3 over 1, which means what, Brianna? If I'm graphing these points to get from one point to another, where do I move? How do I move?
Up 3
Yes, ma'am?
and then over 1. Or to the right, excuse me.
Thank you. Up 3 to the right 1. That is our slope. That is our slope. So every time you have an equation like that, the coefficient to the x variable is the slope. All right? It's not always written in this form, so sometimes the kids have to figure out the slope. But the coefficient to the x value, when it's equal to 1y, is the slope. It has to be equal to 1y. All right? So where does this 1 come in? Is that 1 this 1? No, it is not. This 1 is not this 1. Denise?
This is not the right time to ask this question, we just did Fred.
Yes, ma'am.
Yeah, did Fred. You keep talking about function and rule and equation. I'm not understanding the difference.
Okay, I'll go ahead and explain that now. A function it shows a dependency. And we've kind of danced all the way around this morning when I said, does the number of blocks depend on the step number? If that answer is yes, then it is a function. If the answer is no, it's just an equation. But in elementary and sometimes 6th grade, they don't call it a function, they call it a rule, but they're headed toward function, okay? Now, you have to be careful with functions, which is what this whole conversation with Rochelle about switching those, you have to be careful about that. When I will never forget, one of my early years teaching, I had a special ed kid, and it was early in inclusion, and I am totally untrained to handle special ed. I had no special ed training at that time in my life. So this little blonde boy walks in, middle of the year, he has an attitude, you know, so I'm having to deal with him, and I was trying to teach functions, and I was using the formula, distance equals rate times time. Distance equals rate times time. And I said, distance is dependent on your rate and your time. And he's sitting back here going, you know, like that. And I finally said, Johnny, do you want to explain what you're thinking? And he said, we never get in our car and say we're going to drive for 4 hours and see where we go. We always get in our car and say we need to go 500 miles. How long will it take? So the time depends on the distance. The distance does not depend on the time. So then I went down and looked up his file and found out why he was classified as special ed. It was a behavior issue. So in that case, both of those are functions because one can depend on the other and one can depend on the other. So in that case, the inverse of a function is a function. That may be more than you needed. So in this case, the inverse of this function, which is what Rochelle was doing, the inverse, could be a function, except for this grade level that this activity is planned for, we do not talk about inverse functions. So we would want them to put the step numbers independent of the other. That help? Yes. Okay, so now we're back to the grade level we're supposed to be in for this. What if we graph this? Do you have a blank graph on there since you didn't do all three parts? If you would graph this for me, these ordered pairs. Graph these ordered pairs for me. Graph and then I'll talk to you about what you're thinking. Because I can tell you're thinking hard. I ain't gonna separate you two. You're like a husband and wife.
Well, they're wrong.
Bickering all the time. Brandon's no job. He's like a little kid in the backseat.
Yeah, Mom.
So just 1, 4, 2, 7. So you're graphing these 4 or 5 ordered pairs, okay? So that we can see how they graph.
What you want is to just grab it from the function. I just throw it in my wireless.
I'm gonna go get the opposite.
One first, and I know it's my soul.
Graph it first.
No, I didn't.
I know that means something.
Okay, let's come back together. So, Aubrey, when you graphed this, was the graph of this equation, function, rule the same as any of those others? Or what was different about it?
Well, one of the things Ashley noticed is that if you were to continue a line on the other ones, they would go through 0. But
Okay.
if you did a line on this one, it wouldn't. It would be somewhere around 2, between 2 and 3 years.
So it would not go through the origin?
No.
Okay, so on all of the things we've done so far, if we extended this, even the other one that Rochelle did, it would go through the origin, the 0, 0 pair, the origin. But when you graph this one, if you extended it, it would not go through the origin. Is that what you're telling me? Okay, would not go through the origin. So, Rochelle, do you agree
with everything she says?
Yes? No, just with the origin piece.
Yes, that if it does not go through the origin, that means it is not
That's not what she said. She said when she graphed this,
Oh, yes.
it did not go through the origin.
Yes, I agree.
Did not go through the origin. Good. So, Tim, where did it go through that y-axis?
It went through the y-axis at, the order pair 0, 1.
0, 1. So it crossed the y-axis at 1. Where do you think that 1 is? Up here. It's this one. So this one, I'm sorry, I actually just spoke right. So this one has to do with the slope. This one, the plus or minus, whatever is here, has to do with where it crosses the y-axis, and that's called the y-intercept. If it crosses the y-axis anywhere except 0, it is not proportional. Because it's gonna have a plus in there to move it up on the y-axis. Yes, ma'am?
Alyssa, right? I think Alyssa's, she kind of asked you a question first before she answered. She asked you the question, do all of them have to be a yes? Meaning like, comparing x's, the recursive rule, do all of those things have to be in like the process? So if for whatever reason the students weren't able to come up with the formula or function, they could have determined because the process across from x to y is not.
Yes.
Because a lot of my students in teaching this would have seen, it's the same 1, 1, 1, 1, it's the same on the right side, 3, 3, 3, it's proportional. No, because then the process across would be a no.
Right. The process in here would be what, I don't remember who answered me, but I think it was Amanda, said 3x plus 1, correct? So that process would tell you that it is not proportional because it has that plus in it.
So yeah, all of them have to be a yes, or check off.
I don't know what you, Pam?
I'm curious to how students would get to the multiplying times 3 when on our differences we end up with just plus 1 and a plus 3. What would make them decide that it's times 3?
Well, they can do the plus, and after they do several of the pluses, they'll see a shortcut in multiplying. It just takes lots of practice, this is not the first one that those kids are gonna see.
I'm just wondering in 5th grade, how would they?
Yeah, I don't know, you have to ask your fifth grade teacher.
We can talk later.
Yeah, you start playing, really?
Cause I know that, cause I teach 7th and 8th grade math, and going through that process, I'm like, I do still see a lot of students struggle, and I'm like, well, how would I kind of bring it down to where they could find that pattern on their own, instead of telling them, yeah, that plus 1 is when x is equal to 0, because that's where we start. Like, when we start with nothing and about all that kind of things, and I was like, well, if we add that processes that how we had with all the tables and everything like that, I'm like, oh, I see a plus 3 pattern on the right side. Well, if it's a plus 3 pattern every single time my my x changes, then in the middle, just write it down. For number 1, oh, plus 3, because I'm adding 3. But what can I add to get that to that 4? Well, I know the plus 3 will always be consistent. So if with x equals 2, plus 3 plus 3. Well, I can't add any more plus 3 because I'll get higher than 7. Number x is equal to 3, plus 3 plus 3 plus 3. Well, what is common that they have to be added with in order to get that y value that you want? Oh, 3 plus 1 is 4. 3 plus 3 plus 1 is 7. 3 plus 3 plus 3 plus 1 is 10. Oh, 3, 3, 3, 3, 3, 3. Isn't that also what we learned with grouping? So 3 times 1, 3 times 2, 3 times 3. And that was the only way I could think about, well, how could those kids get the really basic patterns of what they need? And that's what I was just kind of toiling with.
That's exactly right. So that process column is extremely important in here. And that process column is extremely important in here, and you have to have that repeated addition
Right,
to
that's
lead
what
them.
Rochelle wrote, she
Yeah.
said repeated addition,
Yeah.
they would figure out that it's multiplying.
So we've determined by the table, we've determined by the rule, and we've determined by the graphs that the ones that y'all all solved, not this one, are proportional. So what you need to have the kids do is to be able to explain to you all 3 ways. And Rochelle, don't give them the answer anymore. You did, you just gave them. So, looking at the 3 three different problems. Is there any relationship between the rules for the three different problems? We have, y equals 2x, y equals x, and y equals 3x. Those are the three rules. Do we notice anything there? And you may speak up.
Oh, I thought you didn't want to ask person. Because Renee actually, when she was discussing it, she said, since y equals 1x with the, what was that? That was the, thank you, that was with the rhombus. Plus, y equals 2x, which was the trapezoid, you end up with three pieces, because we had 1x plus 2x equals 3x, and 3x was our total, but that's what Renee came up with.
Very nicely done, Renee.
Yes.
So the one from the, whichever one it was, rhombus,
Rhombus.
plus the two from the trapezoids is really the three from the total. Very nice, very nicely done. Okay, so thinking back to how we worked this problem, or how y'all did, if an outsider had come in, what would your principal think? Would you think your kids are thinking and learning, or would you think the kids are having a fun day, play day? I mean, a play day, not a fun day. What would your principal be thinking? Ashley, how about yours?
I think they would be thinking and learning. I think it depends also on what stage of the process that he came in on.
It's absolutely true.
One thing that, no offense, principals and administrators, but it's come up before. Sometimes principals will come in and say, well, what are you learning? And I'm like, I don't know, we're still trying to learn it.
Yes.
Well, tell me about what you're doing. It's like, I'm still trying to figure out what I'm doing before I can tell you. I think, so.
That's a very important point.
And then I get docked because like they have no idea what they're doing. It's like I don't want them to know what they're doing until they, they put it together.
So that's a point that Denise needs to handle when she's dealing with the principals, that if you walk in early in a discovery lesson, the kids may not really know how to tell you what they're learning or even what they are learning. But as the lesson goes along, then they can explain more readily what they have figured out, what they are learning. So principals need to know that it depends on the time of the lesson when they come in as to whether the kids can actually answer the question, what are you doing, what are you learning? Yes, ma'am.
Is it a principal? I think it was right. Is it done?
No.
Oh, okay.
The one sitting there yesterday, yes.
Okay. Right.
Is it customary for the principal to ask the teacher, like,
No.
They ask
so
the
they
students.
can, I know, but so they can understand, like, if the student, like their answers are similar to what we're doing that day?
I don't know.
Never had a principal.
It
Pam,
depends
no?
on the school, because a lot of schools you have to have your objective or your key on the board. So when the principal
So they
walks in,
know,
they
yes.
look and say, oh, they should be able to tell me blah, blah, blah. So when they go up and ask the loaded question, what are you learning today? Sorry, I was laughing because I always have a speaker of the house that reads it to everybody.
Okay.
Speaker of the house, so that when the principal does walk in, they'll say, we're doing this and that, so
So they look
That's
up
a
at the
loaded
board,
question,
yeah.
Right. Well, and I've had a learning coach actually recommend before you start in case somebody walks in and asks you a question, this is exactly what you tell them.
But that always doesn't work. Okay, Sandra has a hand up.
Well, that goes back to yours and my discussion on the way to school today about what you put on the learning objective. So if it's inquiry, you can't give them the answer.
Right.
And part of what we've done with principal training is to explain to principals that the learning objective has to be crafted differently with a direct instruction model versus an inquiry by the kind of model. And so it still can be, well, we're learning how to do, or at the end we'll know how electricity, flows or something like that.
Well, if a principal is going to do a walkthrough, I mean, if they're gonna require that we have our lesson plans available digitally or paperwise, if they know, like a schedule, I'm going to walk through these classrooms, if they could take, just about 5 minutes or 3 minutes to take a glance at the lesson plan, before they come in and then just observe.
That won't ever
Foolish
happen.
girl.
Alright, Jen, just quickly.
So if you're writing or you're doing an inquiry lesson, could you have the question they want to answer? You want them to be able to answer. By the end of the lesson, I will be able to answer the question, blah, 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 blah.
Yeah, how do you accommodate or manage?
So when your principal comes
I-
in and they say,
But
well,
you
at the
can-
end of
it
the
doesn't-
lesson, I gotta be able to answer that
It doesn't
question.
have to be that language though.
Right.
But it says the same thing.
And Denise will address that with the principals in here, right?
Well, I would like,
We actually already have, but remember, telling is not teaching, and it's repetitive, it has to be repetitive, because this is new information to them. I mean, many of them don't believe in inquiry. So, it's over time, and our job is to show them the research about, in fact, when Mark Estrada came in, he asked explicitly if I would go back to something that I had told him earlier about, if it's a concept, in general, it's best learned through inquiry. If it's a skill or a process or a chart, it's generally best learned through direct instructional model. So he asked me to repeat that for the principals. And so they're not gonna get it the first time, because Mark didn't even remember it, although he knew it was important. So that's gonna be what Denise is gonna be working with.
Tricia, have your hand up just really quickly.
At our school, we have our unit organizer posted outside our door for that specific purpose of them. When they're doing a walkthrough, the daily lesson is paired up with the bubble, and the bubble is usually the teeth that we're studying that day. So
it's posted
so
that
they
when they
know
walk in,
when
they know.
they're coming in.
That's only the sim model.
Right, yeah, that's the same model.
So
But that's
going,
only used at middle school.
so going back to the algebraic habits of mind that we've already discussed a little bit. The first one, and these are not in any kind of hierarchical order, it's just the first one he wrote down. Doing and undoing. Did you do any doing and undoing in this activity? Let me call on the line. Ashley. Did you do any doing and undoing in this activity?
Yeah.
Okay, can you tell me where?
Well, like starting with the pattern blocks, putting the steps together, and then physically taking the steps in the set sections and pulling them apart and seeing, well, how much is it increasing each time.
Okay, so we did that as algebraic habit of mind. You do that a whole lot more than you realize just in normal life. You really do. So how about building rules to represent functions? They're all over the room, so yes, we did that. So, abstracting from computation. There are a lot of abstracting going on, right? Are there is? Okay, so we're thinking algebraically all the time. I want to talk a little bit about the importance of data tables. Children from K up should be aware of data tables and should be completing data tables. It helps them to determine which number goes in which column. We've had that huge discussion about that today. It also helps them to visually and cognitively tie that table to the data, to the graph, to the rule, to the equation, whatever you've got. And then in K1, the teacher usually has them up at the carpet with the chartboard, and she does the table, them telling her the answer. In grades 2 and 3, the students begin to record the data table, but the data table is provided for them to help them organize. And then beginning in grade 4, then they should be able to create their own tables and complete them. Okay? Yes, ma'am.
Oh, I just was saying, that was a question I was gonna ask, because we get college students in our general science course, elementary pre-service teachers, who cannot take raw data and put it into a table. This is very important.
It is extremely important. And then we've already talked a little bit, because Brenda brought it up, about the recursive rule. This group said that they kept adding 3. Well, that is the recursive rule when you have to have the number before it. I don't know why I don't use this thing. You have to have the number before it before you can get to the next number. That's a recursive rule, okay? So if
if I wanna get to the 1,000th number of dogs here, it's gonna take me a while using recursion. So we really want to get the kids to get to the explicit rule, which is the going across. What did I do to X to get to Y? And does it work for every ordered pair? So we have a recursive rule and we have the explicit rule. And we want the explicit rule by the time the kids are in 8th grade actually, or 7th grade now. Yes, ma'am?
I know we use rule as our general term in 5th grade. We don't, are we ever gonna say recursive and explicit, and how should we differentiate those for them?
Well, the recursive rule goes down the column.
Well, yes, and
And the explicit rule,
I guess just like terminology and vocab that we should use. Should we just say rule, like the rule on the outputs and the rule for the entire table?
I don't think it's important for 5th graders to know these words. They can if you're ready for them to. But if they don't know those words, it's okay. You would just say this pattern going down the table and the rule that goes across the table, okay?
They do have to know function. What's
They-
the function?
They do. Okay. So instead of saying rule, you could say function if it is a function. And most of them in elementary school and middle school, they will be functions. All right, so where does this begin? If you're in the lower grades and your principal says no calculator, no calculator, no calculator, then you're missing a lot of opportunities for problem solving. For instance, what if I gave a problem, you're in 2nd grade, and I give you this problem in a calculator. Can you make 50 if you start with 2 and you add 2 repeatedly? I know you know, but I'm talking to 2nd graders, okay? So could you make 50? Well, they would have to explore that on their calculator, and they would discover that yes, they did get to 50, starting with 2 and adding 2 each time. So these are the teaks. It's called skip counting. These are the teaks that's in, okay? These are the teaks, K1, 2, and 3. Sometimes they do it on a hundreds chart. Many times they do it on a hundreds chart. So here's another question. If we start with 3 and we add 3, can we get to 50 evenly? We cannot. So some questions you would ask, and the kids need to realize this, questions you would ask, what other numbers than 2 can you use to get to 50 evenly? So that would be what, boys and girls? 5, 10, 25, and 50, that's the weird one. How many numbers can you find to get to 50? What numbers will not get you to 50, depending on what you start with, and we're sticking with 3 here. Y'all were answering if we were sticking with something else. What numbers will not get to 50? Let me rephrase that, 'cause I'm kind of stupid. What number can we start with and repeatedly add that will not get to 50? We know 3, 4, 6, 7,
The ones we didn't say before.
So where are we headed with this? Why is this important? What numbers are these in relation to 50? Factors. So we're talking about factors and non-factors. You don't have to call them that, but that's what the thinking in the kid's mind will, that little seed has been planted, so that when they get there, they'll know more about it, okay? So this is why that's important. Eventually, instead of skip counting here, they're gonna come over here with input-output tables, and they're going to graph. All right, now what are those teaks?
That kind of graph?
Yes. Grade 6, 6C, 7-4C, 7-7A, 8-5F, Algebra 1, 2C, and it's just talking about X and Y. And you see that right there? That's a proportional relationship. Y equals AX. You see this one right here? Y equals X plus A. Proportional or not? Not. So that's where we're headed, okay? So with the 7s, look where this crosses the y-axis. Where does it cross the y-axis? 7. Okay? Just like this one up here, cross the y-axis at 1. So you see how important it is for this thinking to begin early,
because it's headed toward this in middle school. Alright, so that vertical discussion that you need to have with your K-1-2 teachers, 4-5 teachers, needs to involve this at some point in time. Okay? Now, according to Frank and Levy, there's 3 levels of justification. The first one is appealing to an authority figure. It's just true because the teacher said so. And you all have told me one of those things. How do you divide fractions? Lift and multiply. Why? Because the teacher told you so. She didn't explain it, she just said, this is how you do it, okay? And then we look at particular cases or examples, all right? We looked at particular cases here. We looked at 3 particular cases here, all right? And then we get to generalizable arguments. We generalized that if there's a plus here, it's not proportional. If there's not a plus there, it's proportional. So those are the 3 levels of justification, and you want the kids to get to that 3rd level before they leave your classroom. Right? Not before the end of 8th grade, not before the end of Algebra 2, before they leave your classroom. So you want them asking why. Anytime you say, this is how you do it, you want them asking why. And, more importantly, you want to be able to tell them. Yes, ma'am?
Also make sure that they know that there are other ways too.
Oh, absolutely.
Always.
Always other ways to do
I
things.
think that when they come to 5th grade and they really struggle with long division in 4th grade, they give up. They're like, I don't care, I'm not doing it, because I don't get it. And so, yeah, I'm just gonna get it wrong anyway, so I'm just gonna guess. But they've never been shown any other way to do it.
Probably never with,
And I think that
with
that's the
pattern
only
blocks.
way they can, because it's the only way their parents know how to help them too.
So base 10 blocks, pattern blocks, all those
Right.
things we talk about, if you pull those out. So there again, another vertical alignment conversation with those grade levels lower than you. It's got to happen, and you've got to have principal support in that. Because you can't have a principal saying, well, his scores are really good, so I'm gonna let him do whatever the heck he wants, but the rest of you have to do this. Okay? You can't have that. So let's talk about the student displays. These are so important because number 1, it holds the kids accountable. They have to be able to explain what they did and why. Number 2, they learn from each other. Some of you learned from, well, maybe not because y'all are teachers, but if you were students, you may have learned from Brenda's example a way to do it that you hadn't thought about. Now, you got yours right, but you hadn't thought about doing it that way. So there's another tool for their tool belt. They learn from hearing and seeing other students explain their thought processes. So y'all know this, I'm just gonna put it up there so that when they print out this PowerPoint, you'll have it as a reminder. Middle school is really that stage where they're going from needing a whole lot of concrete to abstract. And it doesn't happen overnight. It doesn't happen in the summer between 6th and 7th grade. It happens gradually, okay? But they are beginning to have the sophistication to go from the concrete to the abstract more readily. And you have to understand that. Yes, ma'am? You look like you have something to say. Okay, so remember this? This is what this whole lesson was about, making connections. Did we make connections here? Did we connect the graph to the table, to the rule?
Yes.
Did we connect those to proportionality?
Yes.
Did we connect them to non-proportional? What other connections did we make? Did we decide that we could switch the ordered pairs here and it may, here, and it may still be a proportion, it may still be a function, but it's not using the correct number by convention for the independent and dependent variables? Lots of connections were made. So when I plan my lessons for my, in-service teacher, pre-service teachers, my class is on Monday morning. Lovely time to have a class, you're all half asleep or hungover or something. So my class is on Monday morning, and the first thing I have to do is determine which of the teaks I'm going to model an activity for, because I'm trying to teach them how to teach math. They supposedly know the math because they've had math courses, content courses before they get to me. My students are seniors, I only teach seniors and graduate students.
So I'm showing them activities, much as I do you, to help them learn how to teach the math. So the first thing I do is decide what concept I want to use, all right? And then the second thing I have to do is decide how the students are going to show me that they know it. Show me what they know and how they know. Are they gonna make a product? Are they gonna work 25 multiplication problems in a row? Okay, I have to determine my assessment. It may not be formal, it may be informal, but I have to know what I want them to show me and what I want to hear coming out of their mouths before I make my lesson. Then I create my lesson to help the students be able to do what I want them to do, to show me that they've learned, and what I want to hear when I'm walking around listening. Because that's what I'm doing. When I'm not walking around for exercise, look at me, I don't exercise. But when I'm walking around listening to y'all, I'm trying to make sure I'm hearing the right words coming out of your mouth. And sometimes I stop and listen to make sure, because I heard something I wasn't quite sure of, but if I listen longer, yeah, it was right, they were just using a negative example, okay? So that's extremely important. So it takes me a minimum of 6 hours to create my PowerPoint for a 3-hour class. I have them for 3 hours on Monday morning. 6 hours to create a PowerPoint, yes ma'am?
What do you mean by a negative example?
A non-example, yeah. So it takes me a minimum of 6 hours to create it. I do that on Monday afternoon. You know, I teach my Monday morning class, okay, we got this far. Next Monday, this is what I wanna cover. By Tuesday morning, I'm changing the PowerPoint, because Monday night in bed, I'm thinking, that's not gonna work, you know, I need to change this, I forgot to add that. So it's a long process, planning these lessons, okay? But it's extremely, extremely important, and I do use PowerPoints because, you know, I am at the university, that's what we do, okay? And I write almost everything in my PowerPoint, my questions, almost everything. Of course, we do bird walk a time or two like we did in here, you know, with the questions that kind of extend the lesson a